Oh, I think. How about we start with a quiz? Okay, quiz for the final phase in SDLC, system operation and maintenance. Okay, let me see how many questions in my quiz, or 10 questions. Okay, one moment, I'll get the, this is join code first, yeah. Oh, which one do you all prefer, the lecturer pace or student do the quiz on their own pace?
Lecturer.
Lecturer. The rest?
Sorry, what's the question?
Sorry?
What's the question?
You want the student phase or the lecture phase, Noel?
Yes, yes.
For me,
Phase.
it's okay. Both is fine.
Noel?
So what phase?
The quizzes.
Okay. Both also okay. Lecturer.
Both also
Lecturer.
can. Okay, so I'll get the lecturer space. One moment. And the name is in fact instructor pace. Let me find. Okay, so it will show the leaderboard. It will show the timer. Participants will see the countdown and get extra point for each question. Music will be played on your device. Okay, let me copy the join code for you. One moment. Assign. You would see the link in your Google Classroom already. And I will start the recording. Oh, someone is already in. Farah is in. Can click this link. Okay, 3 of you already in. So shall we start? Okay, I'll click the start here. System operation and maintenance. Okay, yeah, correct. This is explaining about help desk. We provide assistance for the users once we help them in giving information about how to go about it, then they will be able to solve the problem themselves. Okay, next would be question number 2. So far so good. Yeah, that should be automated support. Once you see email responses, and then there's FAQ, all right, definitely automated support. Okay, third question, let's go. So which one is which?
This one I confused a bit.
You confused? Just remember maintenance cost. Initially, it will be high, and then as it goes to the next few years, it will be constant. And when it's reaching its like a useful life, okay, this is where when we get more maintenance requests, so we know already that it's time to replace the old system with the new system. So at the end here, it's increasing towards the end of the system's life. So the one with the bathtub curve is the maintenance cost. Operational cost will be a constant. Okay.
Okay.
Next question. Okay, let's see. How teacher answer this? Oh, still can I remember? Oh,
Yeah, it's me.
correct. When you check this statement, kan, Farah, there's nothing wrong. There's no errors. Means even if I am the SA, I didn't do any, like I didn't give priority to this maintenance request. The user can still use the system. Okay, like you can see the modification is meant to increase the functionality and efficiency. So we're trying to make the system to be more perfect. Okay, perfective maintenance. It's not about adaptive maintenance as well, because some adaptive maintenance, this is something like a required, okay, due to the changes in the business or changes by the customer. Means in terms of whether it is having a high priority or not, then this one, it's not in a, like urgent, you must do it. It's just a matter of increasing the efficiency. So this is perfective maintenance.
Okay.
Right. Next question. Almost to the end.
They have to read it. So
Or,
small.
or you can click to enlarge it.
Oh, can
In
enlarge
fact,
ka? Oh, I didn't know.
yeah, you can enlarge it like this. In fact, the one that you need to see is this Oracle user group. Okay, Oracle user group. Do you think this one is set up by Oracle themselves, or is it set up by the user? If it's set up by user, normally it's to act as arbiter in case there's any dispute between Oracle and their customers. But then this one is definitely a user group set up by Oracle themselves. Okay. So if it's set up by the software manufacturer, then it's more about getting feedbacks from their users, okay, their customer using Oracle products, and also to share ideas. Okay, next question. For help desk personnel, definitely need solid understanding of the new system. Not only technical skills, but he needs to have technical and interpersonal skills because they need to talk with the users. Right, leadership skill is not required. Okay, next question. Oh, now is question 6. Next should be question 7.
What is operational life?
Operational.
Yeah.
Operational life means when the users start operating the system. Means remember if we refer to SDLC means right after the system implementation, the output from the system implementation phase is operational system. Okay, so starting from there until we no longer use the system. This is a useful life lah, operational life.
Oh, okay.
Okay, 2 more questions, I believe. Let's continue. Yeah, this is definitely a corrective maintenance because if the user's PC has this defective network cabling, definitely cannot access the system if it's stored in the server, okay, the company's server. So it must be replaced. Okay, any defective cablings must be replaced immediately. Otherwise, I cannot continue using the system. Okay, so correct. It's a corrective maintenance. Question 9. See whether you can identify or not. Yep, this is adaptive maintenance. So if you take a look, here it mentioned employers must have this EF form, means generate this EF form, and then if they are unable to generate and distribute this EF form, means they can be fined RM 200 to 20K or even imprisonment, not exceeding 6 months. So in fact, this is like what do you call that? The legislation rules set up by our government that companies must follow. So the question is, all companies should ensure that their payroll system is in compliance with the Malaysia's labor law. A good example of adaptive maintenance. Okay, I believe we have reached to the last question. Let's get to this question. Okay, in fact, I took this from our notes. Okay, one of the exercise question, I think towards the end. Okay, conducting a thorough analysis of system requirements can reduce perfective maintenance. What does it mean? If you all still remember one of our questions just now on perfective maintenance, we want to make it perfect by adding features that can provide efficiencies to the overall system performance. So if we can foresee or predict that this particular system requires certain things, okay, during the system analysis phase, is where we get the system requirements, right? Then we can reduce the perfective maintenance, means we have already incorporated some sort of like perhaps non-functional requirements. When we have already foresee, okay, these are the requirements that the users might request for. After a few years, the system has been operational, then there's no need for them like to do this perfective maintenance during that time. So if you conduct a very thorough analysis of system requirements, it definitely can reduce perfective maintenance. For corrective maintenance, this is more like problems with the codes, okay, for the hardware, corrupted driver. Just now we have seen damaged network cabling. Conducting a thorough system analysis to find out the requirements will not reduce the corrective maintenance. Okay. So, and the quiz, let's see the statistic. Ta-da! So only 3 students. So definitely everyone is in the top 3. Okay, this time class accuracy is much more better, 73%. Yeah, the toughest question, help desk personnel answered incorrectly. Because instead of just having good technical skill, must have interpersonal skill as well. Oh yeah, the picture, right? The Oracle user group. And then 2 questions less than 40%. Yeah, the help desk, and also question 10 just now, perfective maintenance. This one is taken from our exercise in the previous chapter, so you all can have a look. Okay, let's
Okay.
exit from our quizzes. All right, the time now is almost 12 o'clock, 11:52. Why not we go for a 5 minutes break before we start with the lecture?
Okay.
Okay.
All right, so I'm back. Let's see. Okay, chapter 13. I'm sure you have your chapter 13 ready. Okay, I'll start the recording now and present my screen. Okay, I have two more questions ready in the class activity. This is from our system implementation. I think I want to give you all this question this week. Okay, under what circumstances or situations would you consider a direct conversion method to be preferred over a parallel conversion method? Okay, so this is using YouTube video for collaborative learning. Means you all can reply to each other. You can even edit your own answer lah. Okay, we'll give it until next Monday. Okay, next Monday to answer this. And I click answer. Okay, let's see the previous one. Yeah, already written. Okay, good. Oh yeah, regarding the test, my reviewer already gave me feedback. Just that notice for Ferris answer about the ERD with the supposed to be one and only one to be drawn. Okay. But then for Ferrer answer, you only use one vertical line, right? Okay, but then she agreed with me because from our notes, we do have the ERD relationship diagram for one and also one and only one. And then the fact that the question also didn't insist that you should use should show the cardinality. Okay. Otherwise, if the question asks student to show cardinality, for cardinality, you must show the minimum and maximum. So if you just have one vertical line, that will you will lose marks there. Okay, for cardinality, you should have a minimum and maximum. So if it's one only, then you should represent it as two vertical lines, one and only one. Okay, that is about the E test. Okay. Okay, let's go to our lecture. The final lecture, this is our final chapter, chapter 13, the system development methodology. Before we start, I want to show you all this diagram first. You can go to your slide 7, and this is the same diagram. Just to give you all a preview, what are the concepts that we will cover. Okay, for this particular topic, we need to understand in the context of system development methodology, we need to understand what is methodology first. So we will see that we need methodology because it helps us to complete the activities that are included in the models. Okay, and to do that, to complete the activities, we need the techniques as well as tools. Okay, so to understand what is a methodology, okay, in general, we will go through these three concepts: models, techniques, and tools. Okay, for models, models means it represents the real world. Okay, a representation of the real world. We have several types of models, like a physical model. This is what how a physical model looks like, an airplane model. We have a model for cars, for buildings, and so on. And the one that more relevant to our context would be the system development model. And then normally our models are, as what you can see in our previous phases, we have learned lots of graphical models. Such as the entity relationship diagram, we have the data flow diagram, and so on. Okay, so this is in fact a DFD. Besides system development model, we do have project planning model, means this model represent how we should complete that particular project. And normally for system development, we have two main options. The first one is using the PERT chart, or the second option is using the Gantt chart. The one that you see here is not a Gantt chart, but a PERT chart. I think this one is not included in our syllabus. All right, I'm not sure. Have you all learned a PERT chart in any of your other courses? Network diagram.
No, I think.
Belum. Okay. This is normally used for project scheduling, saying that, okay, say I have the first task is interviewing user. Okay, this is the first task. Interviewing user requires 4 days. And then at the same time, you also want to distribute questionnaires. So that is task B, to prepare the question and then send it out to the users, collecting back all the responses. Perhaps it requires around like 6 days. So if the task can be performed at the same time, so you can see that task A and B, okay, it is run parallel, and then the moment A completed, the next task can start. Okay, the moment B has been completed, the other tasks like D and E can start also. So this is something like how we want to plan our tasks or activities that leads to the completion of the whole project. So say at the final task, task I here is something like a system changeover. Okay, a system changeover, and that one it will also include the duration required. Okay, one moment. And my neighbor is making very loud noise. I need to close my door first. Sorry about that. Let's see, do I still have my mic on? Yes. Okay, so normally the project manager or system analyst will check on this scheduling, all right, to see whether they are right on track. If they are not, means they are delayed, then they need to like make some decision to keep the project back on track. Okay, so I would say if I look at this example 26, I see the number 26, it might mean it requires, if these are all in days or weeks, then it should either be 26 days, or if it's in weeks, then the whole project duration requires 26 weeks, depending on what kind of project it is. Okay, just to let you all know, models has the activities that need to be completed. Okay, like the project planning model shows us the activities scheduling. Let me see. Okay, so the second one is the techniques. Okay, so we already know that from this model, it represents the important aspect of the system development. It represents the important aspect of the project planning. These are what we need to complete according to this model. So next, the techniques would be the guidelines. The guidelines that SA will refer to complete the activity. Okay, so we have this model. Okay, we already know what are the aspects of the tasks that need to be completed. Next would be the guidelines. What's the guideline to complete that particular activity? So it can be a step-by-step instructions. Okay, for creating a model, like what we have here is DFD. Okay, what are the steps needed to draw a data flow diagram? We already know that we have, first of all, to show the overview of the system, we can first come up with the context diagram. Okay, showing the boundary of the system, where we can see all the external entities with the system in the middle, which is the process 0. Then the next step would be we start drawing the diagram 0, the explosion of the process 0. And then after that, we can further explore any of the processes in the diagram 0 to get the diagram 1, and so on. So these are the steps, right? Another example would be, say, instead of an instruction, perhaps a know-how or advice. Say during the system analysis phase, we have the fact gathering, right? And then one of the technique for fact gathering is interviewing. Okay, so what's the general advice for collecting information from the system users? The techniques for conducting interviews, the do's and the don'ts on creating the questionnaires, what you need to do before you do the observation, system observation, and so on. Okay, so the one that I mentioned just now would be on the user interviewing, the fact-finding technique during the system analysis. And for the GFD, we are referring to the data modeling, right? Now, the next one would be tools. Okay, so we already know what's the guideline to complete the activity. Do we need a software to help us to complete the task, say, faster, to speed up our whole task? Then that means we need tools, right? something like a software support. SA can use a software package to create the models. In our previous chapter, we have learned about the case tool, where in the case tool, it has the options for the SA to create the system models. There's also the capability to generate the codes, right? To generate the programs. So basically, once we know what's the technique, then the next step would be we need tools to do that. So something like a aid, all right, to help us out. And then for diagramming tools, this is also one of the software packages that will help us, especially when we want to create diagrams. Here, example given is visual. I think you all were using Smart. Is it Smart IO? Was it?
Draw.io.
Oh, Draw IO. Yeah. Okay. Also forget what's the name is. Yeah, Draw IO. Good. Okay, so that is specifically a diagramming tools. So it's much more easier if we use tools to do our tasks and so on. Others would be tools to create or generate the report. This one is much more nicer because towards the end, like when you want to come up with a report design, it would be nice if you can have these tools that you can do a drag and drop, yeah. And then IDE. IDE would be the integrated development environment. We use this for our system development. I think now you're using the one for Visual Basic. And then others would be like NetBeans, Eclipse, and so on. The last one mentioned here, the project management tool, used to create models of the project tasks and the task dependencies. That one, if I go back to here, we are looking at the project planning model like the per chart. So we can see these are the tasks and the dependency between the tasks. Like task C cannot start until both task A and B has been completed. So if task A can be completed in 4 weeks, task B requires 6 weeks. Even if task A have already been completed in week 4, task C, we cannot start with task C yet. So that's why the earliest start for task C is 6. We put it as 6, waiting for the task B completion time, which is 6 weeks. So showing the task dependencies, as mentioned here in the project management tools. It is much more nicer if we have tools or software for us as well. Okay, and finally, we can put in the whole concept of the methodology. For all methodology, we can see that it is separated into several phases or stages. And normally, these phases must be carried out in sequence. And what we can expect from each of these phases would be output. Means after the completion of each phase, there will be an output on deliverables, right? We have seen for each of the methodology, it requires several techniques, okay? And then a few tools that can be used to help SA in completing their tasks. And another thing for methodologies, we cannot run from documentation. Normally, documentation will be produced throughout the phases of the methodology. It can be the output as well, okay? Like for system analysis, we have the SRD, system requirements document, or SRS, system requirement specification. So this is something like a documentation. It can be used for reference. It can be used for signing off. Signing off means we get the users to verify and get their approval. They will sign and we proceed to the next phase. Okay, so in overall, we need all this for us to identify how the documents, okay, and also the techniques fits into each of the phases in the methodology. Okay, so you can see the last two bullets here. So if we have this methodology to follow for our system development, it will give us the SA something like a sense of direction. Okay, how to go about completing our software development project. So it can improve the planning, the control, and also integration for each of the stages in the system development methodology. So this is the diagram that I showed you earlier on to show you the relationship between models, techniques, and tools. Okay, so let's read what we have here. The methodology includes a collection of techniques and tools. So we have this whole thing is a methodology. It has a collection of techniques and tools. So techniques would be guidelines that help SA to complete an activity. Okay, something like a step-by-step instruction or just a general advice. And collection of tools, these are the software that help the SL system developer to complete the activities. So we need techniques and tools for what? To complete the activities, whereby we have this model. Model would be part of the activities in describing the development. So our whole syllabus for SAD, we have been concentrating on SDLC, System Development Life Cycle. And SDLC is an example of a system development methodology. Okay, so I hope by now you can like realize, oh yeah, we do learn these techniques. Okay, like how to draw DFD, how to draw ERD. And then for procedural design, we have learned about the decision tree, decision table. There are lots of techniques. Okay, and to come up with these diagrams, we can use software to speed up the drawing of the diagrams and so on. Okay, next one would be, why do we need this methodology? Can't we just like just follow our say like no need to go through these 6 phases, okay, as long as I know what the customer want, or I can just straight on do the coding and then show my finished work to my customer. They like it, they pay me. Okay, why can't we just do that? Why we need to stick to a system development methodology? Okay, number one reason, quality. We want to have or produce a quality system or quality software product. Okay, and then number two, we want to have a better project management and control. So when we can further manage and control our project, that will help us in increasing our productivity. We can deliver our software faster, and since you are using tools to speed up our tasks, then we can like cut costs, say perhaps in terms of overtime, or perhaps what other things, hiring additional programmers. Okay, so it will be cheaper. but we are still adhering to the quality standard. Okay, and number 3, why we need methodology would be, you can see the word here, standardize. If everything is standardized, then like what is mentioned here, we can improve the productivity, and then our end results will be more integrated. I like this one, number 3. If say we have this existing stuff, we can easily change them from project A to project B without retraining being necessary. The reason is that we are using a standardized development process, so they already know what are the things needed. So say we have a project B, and then, oh, we need someone who's very good in drawing DFT. How about we get this, say, Noel from project A. I think he's already completed the diagramming for project A, and we can get him to help us on our DFT for the another project. So we can easily change the stuff, because if that is where their expertise are, then we can like fully maximize what we have. Okay, since the development process is standardized. And another thing that I like would be pool of resource. People with common experience, common skills. Like, okay, I have like these 2 programmers. Okay, they are very good at converting from the decision tree and also the decision table into program codes. They are very good at that. They can like even identify whether there's some kind of a problem with the decision table. All right. So if we have these people with highly expertise, they have more experience in that particular part of the system development process, then it will be good for the overall company. Okay, everything is standardized. We want to have a common experience and skills. Even say this lady in charge of the say interviewing, okay, fact gathering for the new project C, but then she's due for her maternity leave. We need someone who can do the interviewing, because as you all know, one of the disadvantage of interviewing is we need experience, okay, to conduct the interview. Then if we have this guy from the project B. He has just completed his interviewing session. Why not we get him to help out in the project C? Okay, standardized development process, and another one would be easier maintenance as well. So 3 main reasons why we need methodology. We want to have a very good quality end product. We want to better manage and also better control of our project. And finally, the overall system development process must be standardized. Okay, the 3 reasons. Okay, this is just a recap on what we have covered from chapter 1 until chapter 11. Yeah, until chapter 11, I believe. Yeah, SDLC system development life cycle. These are the phases. Just now you all were asking about, what is the operational life? Operational life of the system is after we have implemented. The last activity in the system implementation phase would be the system changeover, where we have changeover from the old system to the new system. Okay, this is when the system is ready for operation. So we would say that the operational life of the system starts after the system has been implemented until the end of the useful life, let's say no longer economical no longer economical means lots of maintenance required, the maintenance cost going up, 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 up. This is where you can imagine the bathtub curve, yeah. So we need to change to replace to a new system. Okay, SDLC, we have PD, and then the last one would be O, okay, operation and support. So PDO, planning, analysis, design development, implementation, and finally O, operation and support. Now, these are the main deliverables. PIR, preliminary investigation report. This is where we conduct the preliminary investigation during system planning. Another name for preliminary investigation is feasibility study. Okay, we want to know whether it is feasible to proceed with the proposed new project. Okay, and then for system analysis, the output would be the SRD or SRS, system requirement specifications. And based on the system requirement specification, SA will design the system. A lot of design that we have covered, report design, user interface design, database design. I think it's too many. What else? Procedural design, don't forget we learn about the decision tree, decision table, structured English. So all of that is compiled in STS, another document, system design specification. So the programmers will refer to the design specifications and they will start with their coding. This is where the testing will be done, documentation will be completed. And once everything is done, what we have is a completed system, but it is not operational yet. Okay, it's not operational yet because if you still remember during system implementation, this is where we need to do the file conversion, right? To prepare the site, do the installation of the hardware. What else? Yeah, user training. Don't forget our user training, the instructor based or computer based, or perhaps now we have webinars, podcasts. And then for the instructor base, we have the public training, we have in-house training, either internal trainer or external trainer, right? And finally, the system changeover or system conversion, then we get the operational system. So what you see here are the concepts that we have covered just now. Methodology. SDLC is a system development methodology. We can see the phases carried out in sequence. And for each of the phases, we have the output, okay, in terms of documentation, except for after we have completed the system. And then to complete each of the phases, we have techniques to do that and also tools to help us with it. Okay, so this shows an example of a methodology in the context of system development. Okay, this slide highlights the main feature of SDLC. Like we have sequence of stages. Okay, each of the stages we have the deliverables, and then we must complete each stage before we move on to the next one. And the input for that particular phase is in fact is the output from the previous phase. Okay, and then before we can proceed to the next phase, there's a verification, means we need approval from the client or customer. And look at the last one, freezing stages. SDLC, for SDLC, the stage may be frozen. It means we don't want to do any reworks. Okay, no iteration of work between the stages is allowed, especially when if we see the diagram is like going down, going down, going down, going down. There's no arrow going back to the previous phase. Okay, we cannot see any arrows going back to the previous phase, right? So that one means we are freezing the stages. There's no iteration. So that's why we can see this disadvantage, kind of disadvantage. Say we really mess up with our system requirements. Okay, but we already in a system design. Then what do we do? We need to like redo, reconfirm. Sorry about this. One moment. Okay, so sorry about that. I have to pick up the call. Where was I? SDLC. Let me see. Yeah, the disadvantage of SDLC is when there's a problem with the requirement and there's no rework. But then sometimes they made like changes where if you see that the diagram, it looks like a waterfall and you see there's a dash line going back to the faces. That means it allows rework. That's a minor change. I think I can find you one example. Let me go and find the example first, very quick. That one is from my other course. Let's see, managing information system. This one should be chapter 3 SDLC. Oh yeah, I found it already. Let me show it to you. So we already know that the stages must may be frozen. Okay, here it say maybe. Okay, let me underline this. Underline it. It may be frozen. So this SDLC is also allowed. So you can see that there's an arrow from phase 2 going back to system planning. Okay, like design going back to analysis, implementation go back to design. Okay, or the system is in operation, but there's an error, so they need to go back, do some say another conversion, system conversion, something like that. And then here with the operational information system, go back to this the first phase in SDLC. This is showing the whole system development life cycle. Perhaps there's request to do the maintenance. Okay, so there's a request to do the maintenance. Then the user will fill up another system request. Okay. So this is to show you that SDLC the phases might be frozen where there's no iteration. But as you can see, this is might be. There's another scenario where it might allow iteration depending on the company themselves. Okay. So the advantages, because the stages are in sequence, we have guidelines, very easy to follow. We can go for a quality product because every deliverables need to go through the signing off verification. And then there's a proper project planning and control. Due to the breakdown of the phases, we have deliverables and the stages in sequence. Okay, regarding the completion of stages in sequence. So this will facilitate better project planning and control. Okay, the three main advantages of SDLC model. As for disadvantages, we can find that it's quite difficult to estimate the resources requirements only after having a very limited amount of analysis. Remember, when you are doing the cost and benefit analysis, it's quite difficult for you to imagine, right? One of the disadvantage of SDLC. Another one is, I think I mentioned this just now, not meeting the requirements for user, because for each of the stages here, these are the deliverables that require signing off. Means, okay, the system recommended by the SA because it is economically feasible, operationally feasible, technical feasible. So the user or sign off, okay, approve, go to the next phase. Okay, and then they look at the system requirement. Yes, this is what we want. So they sign off, give approval, proceed to the next phase, and so on. Okay, so the problem is that even though they already sign off, give their approval to move on to the next phase, there's no guarantee that at the end the completed system will meet their user requirements. Okay. Another disadvantage of SDLC is due to the freezing stages. Okay, so that's why you still see SDLC, but with what rework allowed, or we can return to the previous phase. Even though it is a SDLC model, still allow reworks. Okay, let me see. Yeah. And then another thing would be, people would say that SDLC is very traditional, quite traditional. It's a bureaucratic style of work, means too much administrative work. The reason is that it is document driven. Yeah, for SDLC, it's very document oriented. We go for documentation in each of the phases, and people say that the requirements of a proper documentation might slow down the development of the system. So three disadvantages for SDLC. So you might be wondering, oh, SDLC have these disadvantages, so what's next? That's why there are variants of SDLC, derived from SDLC to sort of solve these problems. Okay, the one that it's not good, that people try to come up with a new way of doing things. So we say that these are the variants. As you can see, it is still consisting of several phases, but not every variant of SDLC have all the phases. There are a lot here. This is Jordan system methodology. The one that we'll cover in our chapter is SSADM, structured system analysis and design methodology. This is Mary's. OOA is object-oriented analysis. I'm not so sure about ethics. SSM is a soft system methodology. We have RUP. Okay, RUP is rational unified processing. No need to worry about all these variants as long as you'll know at least one system development methodology is already good. Okay, and then when you go out working, say for your internship, you might be introduced to another new methodology. Basically, they're still the same. There's a model that you need to follow, techniques, okay, the step by step, and what are the tools that you can use to complete your task, right? So these are the examples of variants. So we have the structured system analysis and design methodology as life cycle approaches. We are not covering the rest of it, but the one that we'll cover is the SSADM and RAD. RAD stands for Rapid Application Development. So you can see that there are a lot of methodologies available out there. Okay, more examples of variants. We have waterfall model. Okay, we already know that SDLC is a waterfall model, all right? The naming of the phases might be a little bit different. And we also have spiral model. Looks interesting. How does this work? Okay, so I have very short video. This video is a waterfall model around 1 minute, and another one is a spiral model around 2 minutes. So let's watch this video together. I'll change my tab first. I need to stop presenting. One moment. Okay, so I will select a tab, waterfall process, click share. Okay, I'm sharing my YouTube now.
First model I want to discuss is the grandfather of all life cycle models, and is the waterfall model. In the waterfall model, a project progresses to an orderly sequence of steps, from the initial software concept down until the final phase, which is system testing. And at the end of each phase, there will be a review to determine whether the project is ready to advance to the next phase. The pure waterfall model performs well for software products in which there is a stable product definition. The domain is well known and the technologies involved are well understood. In these kind of domains, the waterfall model helps you to find errors in the early local stages of a project. If you remember what we discussed, this is the place where we want to find errors, not down here, because finding them here will reduce the cost of our overall software development. The main advantage of the waterfall model is that it allows you to find errors early. However, the main disadvantages of the waterfall model arise from the fact that it is not flexible. Normally, it is difficult to fully specify requirements at the beginning of a project, and this lack of flexibility is far from ideal when dealing with projects in which requirements change, the developers are not domain experts, or the technology used are new and evolving. That is, it is less than ideal for most real-world projects.
Okay, so this is the next one, a spiral model.
that we will discuss is the spiral model, which was first described by Barry Beam, which is the professor that we interviewed at the beginning of this lesson, in his paper from 1986 that was entitled A Spiral Model of Software Development and Enhancement. And one of the main characteristics of that paper is that it was describing the spiral model using a diagram, which is the one that I'm showing you here. And this diagram has become very, very popular. And you probably saw it either in this form or one of the many variations of the diagram. So I'm not going to discuss all of the details of the spiral model, but I just want to give you an idea of its main characteristics. The spiral model is an incremental risk-oriented lifecycle model that has four main phases listed here: determine objectives, identify and resolve risks, development and tests, and plan the next iteration. A software project will go through these four phases in an iterative way. In the first phase, the requirements will be gathered. In the second phase, the risks and the alternate solutions will be identified and a prototype will be produced. Software and tests for the software are produced in the development and test phase, which is the third step of the process. Finally, in the fourth phase, the output of the project so far is evaluated and the next iteration is planned. So basically, what the spiral process prescribes is a way of developing software by going through these phases in an iterative way, in which we learn more and more of the software, we identify more and more and account for more and more risks, and we go more and more towards our final solution, our final release. There are several advantages of using a spiral model. The first one is that the extensive risk analysis does reduce the chances of the project to fail, so there is a risk reduction advantage. The second advantage is that functionality can be added at a later phase because of the iterative nature of the process. And finally, software is produced early in the software lifecycle. So at any iteration, we have something to show for our development. We don't wait until the end before producing something. And that, of course, has also the advantage that we can get early feedback from the customer about what we produce. The main disadvantages, on the other hand, of the spiral model are that the risk analysis requires a highly specific expertise. And unfortunately, the whole success of the process is highly dependent on risk analysis. So risk analysis has to be done right. And finally, the spiral model is way more complex than other models, like, for example, the waterfall model. And therefore, it can be costly to implement.
All right. So that shows the examples of variants. Okay. So we have what we have seen would be the waterfall model and also a spiral model. These are examples of system development methodologies. Let's take another 5 minutes break and I'll continue after this.
Okay.
Okay, I'm back. Let's start another recording. Let me present my window. So just now we have seen what is methodology all about. We look at the recap of SDLC, and then we look at the two variants of SDLC. What are the methodologies out there available for us? We have seen the comparison between a waterfall model and also the spiral model. Next would be, what if we are not developing the system from scratch? So if you're not developing the system from scratch means another option would be to purchase. Okay, would be to purchase a package. A package means a software package or a commercially available software package, also known as an off-the-shelf package. So if say we have this software package that is able to satisfy most of our business requirements, or perhaps it can satisfy all of our business requirements by implementing certain customization, then why not? Correct? So in this case, we need to see what are the stages required in order for us to implement this package. It's not like a full system development life cycle because we are not developing a system, but we are implementing the software package. Okay, so let's take a look at the phases. So basically we have 5 phases in implementing the software package. We have project preparation, and then we have the business blueprint, we have realization, and then we have the final preparation, and the last one would be go live and support. Now you can see the word support here. It means if we purchase the software package from the software vendor, then by right the support will be given by the software vendor themselves. Okay. I found this example last night by this software vendor that's offering SAP products. Okay, so SAP is in fact an enterprise-wide application software where they have the enterprise resource planning package for various industries. So whether the business is in a food business or in a service business or in automotive business, manufacturing business, they can, I believe, do some kind of configuration or customization of the software package to fulfill their clients' business requirements. Okay, so if you take a look at the diagram here, it's the same thing. We have project preparation, the business blueprint, realization, final preparation, and go live and support. Okay, I'm just giving you one example of this package implementation phases. Now, let's go to the first 2 phases. The first one is a project preparation. This is something like a kick-off meeting. So I believe if we are using this example between this software vendor and perhaps they have a new client from the say food industry, They requested for ERP software package for their company. Then the first thing that this SAP software vendor need to do is to have a kick-off meeting. Okay, brief on the objectives and so on, setting the plan, the schedule, the project organization, and initiate training. The second phase is the business process mapping. Okay, so what they're doing here is that when we say mapping, they need to understand the business process and find out which among the modules available in the software package are necessary for their client. Say, for example, for the ERP, the company is in agriculture. They want to use this ERP software package. They're interested in certain modules, say perhaps 3 modules out of the available 8 modules. So they need to identify that, because ERP is considered as enterprise-wide system, so it is quite expensive, you see. So most of the SME, they cannot afford to purchase all the modules available in this software package. They need to decide on according to their business process which modules are more relevant for them. So the outcome would be the business blueprint. So based on the business blueprint, later it will be used in the next phase for the system configuration and also customization where needed. Okay, the next 2 phases. Okay, phase 3, realization. Okay, we call it as realization instead of development because we are not developing it from scratch. What we're going to do is that the software vendor, okay, the IT personnel will configure and or customize all the client's business process requirements based on the business blueprint produced in the second phase. Okay, configuration will involve to reflect the organizational structure. This is where as simple as they add in the company profile in the software package. What else? If they have branches, then they need to key in all the details as well. Selecting what is the appropriate transaction need to be included. Don't forget the master data. So in agriculture, perhaps their master file would be their the list of suppliers for their raw materials. Okay, for agriculture, what do they need? They need the seeds of their plants. They need the, what do you call that? Fertilizers, suppliers. So they need a list of suppliers. Okay, that can be one of their master data and so on. As for customization, this happens when the business process of the particular company it doesn't really match with the software package. Means how the software package has been developed. So the way to, like, if you want to fulfill all the business requirements, what they can do is instead of the client, they change how they perform their business process. The software vendor, they can instead help to make changes to the software package. So that's why if we go back here, when we purchase a software package, the software vendor will be able to satisfy most or all of the business requirements, all when there's a necessary customization have been done. Okay. And then phase 4 is the final preparation. Final preparation is where we do the system testing. Then the software vendor needs to give the user training. Migrate data will be your file conversion, yeah, and change over for them. They call this as a live run. Okay, the final phase would be the go live and support. Go live means they move on from the development environment to operation environment. This is they want to check again and then do some kind of fine tuning of to the system to make sure that all the requirements are met. You can see here all requirements should be met. Especially when the customization has been done to the software package. Remember that software package is already there. It has already been developed. Okay, and in order for the customer to use it, they must make sure that it is tailored to the unique environment. And finally, during the support, a software vendor will give support to the users, to the management, perhaps in terms of the reporting, decision making. And then another thing would be the software vendor should have a help desk. Okay, a help desk where the users can report problems. So they need to go back to their website. Let me see. Yeah, there's a support here. Okay, there's also a contact us. They can also see the solutions for the various industry. Okay, so that is package implementation phases are meant for when we don't develop the system from scratch, but we opt for purchasing a package from a software vendor or a third-party vendor. Another methodology, we call it as SSADM, a variant of SDLC. I highlighted this one, SAD, in the middle because this is the title of our course, okay, Systems Analysis and Design, Structured SAD Methodology. You might be wondering, what is this, right? Before we go to this structured SAD methodology, we need to first understand what are the challenges faced during the system development in a system development project. First of all, we want to deliver our end product faster. Means we want to reduce the development time. At the same time, we still want to insist on a high quality of our end product, the new information system. And then if you are working in a software house company, you might be getting more requests on the IT services. Previously, IT services, they call us DP or data processing. Okay, and then the current tools that we have might not be sufficient to our DP personnel. Okay, DP stands for data processing, or we can also replace it with IT. Okay, IT personnel. We can see tools. Tools are one of the things that we need to perform our tasks. Okay, during the system development. And then even though we use tools, right, we have the intention of producing high quality system. We want to speed up our development process, but in reality, there's still a problem, okay, where to design a system that meets user requirements, it should be our top priority. Okay, so with all these challenges, what can be done? This is when a structured methodology for system development is introduced. So from the name structured, it is sort of like giving us the way or method where we can, during the system development, improve the productivity for our IT personnel. in terms of designing systems that meet the user requirements, then structured methodologies will help to overcome the communication problems between the user and the system developer. And since we want to aim for good quality of the new system, then it will help in reducing the risk of system failure. This is I add in this one to a link between this variant of SDLC, a structured SAD methodology, is due to these challenges that system developer face. So we have the new definition of another methodology. Now, I underline SAD here. If you remember, system analysis and design covers the first 3 phases of SDLC. Covers the first 3 phases of SDLC, which is the first of all, the system planning, and then we have the system analysis, we have the system design, feasibility studies where we conduct it during the system planning. Now, SSADM is a waterfall model, just like SDLC. But then the main difference would be structured system analysis design methodology. They focus on the first 3 phases. Okay, so let's take a look at the definition of SSADM. Okay, this is a generic term for discipline from the word structured, means it's a discipline approach to system development. Most structured methodologies, they have the same approach, same general approach. The only difference would be in terms of the breakdown of the stages and the tools, the technique used may differ slightly among the various structured methodology. Okay, and then we already know that for each of the stages, we have part of the activities for the system development and so on, right? Just to show you the difference, not difference, the similarities between SSADM and SDLC. Both are waterfall model. We can contrast, to link this to our next slide, we can contrast structured system analysis and design methodology with RAD. Rapid application development. You can see that for structured methodologies, they have breakdown of stages, and it's a waterfall model, means must be in sequence. But then for rapid application development, some of the steps can be conducted in parallel. Okay, so let's look at this. Another approach of system methodology, RAD, rapid application development, which is mentioned, where is it? Here, If we focus on developing the application quickly, we have this James Martin's rapid application development, or RAD. Basically, it's a team-based technique. From the name rapid, it means it can speed up the system development. It's a collection of techniques and tools that can shorten the development schedules. It combines prototyping, computer-based, spatial management practices, but the most important thing is that they have a very close user involvement. Users are more involved during the RAD. And then we have RAD as a solution to the traditional development methodology, where we have issue with the long development lead times. What we see here. the challenge, one of the challenge, we want to reduce the development time. So to solve that problem, we have rapid application development. And what is the main purpose of using RAD? The main purpose of using RAD is to reduce not only the cost, but then we want to also reduce the development time, because when we reduce development time, definitely we can reduce the cost, and at the same time lead to the higher probability of the system project success. Now, I have a question for you. How do we know that our system development project is a success? Is it a success after we have completed the system changeover and the system start operating the system? Do we know whether it's a success or not? Okay, just to share with you additional knowledge, the criteria for a successful system development project, there are 3. BQT. You can check this down. B means budget. Q means quality. T means time. So your project is deemed as successful if it is developed within the budget allocated, okay, within the time duration as scheduled, and finally, quality means it satisfy the user's requirement, means of high quality system product. So this is where we know that our system development project is a success. BQT, budget, quality, and time. Now, these are the 4 phases in RAD. We have requirements planning. Okay, and this is where between the system developer and the users, also including the management, they need to agree on the scope, the system requirement. We need to get the client's approval before we go to the next phases. So the next phases would be the user design and construction. You can see here that this can be run in parallel. Okay, so during the user design, the user involvement is quite a lot. They're very involved. The prototyping will be done. Okay, build the prototype, show it to the user, get the user feedback, right? I believe we have already covered prototyping in our previous chapter. And then they also include JAD session, intensive JAD session. We have also covered this joint application development. Okay, joint application development, system analysis, chapter 3 under fact gathering, where besides interviewing, besides questionnaire, observation, all those, we can conduct a joint application development. This is a meeting between the software developer, the user, the management, something like a brainstorming workshop for them to come up with the system requirements. Okay, and then right after they have these requirements, then the IT personnel will move on to the construction phase. They will do the coding, testing. All right, once they have done that, then the prototype has been completed. Ask the user to give feedback and then make changes. Okay, so this is in parallel. It can be done in parallel. We can contrast this with the traditional waterfall model. And the final phase would be the cutover. Okay, cutover, something like the implementation phase. Okay, we have the file conversion, then we have the system changeover, not forgetting the training of the user. So the explanation is given here. Okay, explanation is given here. And I found this very short video, 2 minutes video, that cover the overview of RAD, and I want to share it with you. Okay, one moment. Okay, rapid application development. Okay, let's watch this video. All right. So from this video, we can see that there are some additional info that is not included in our chapter. Okay, like advantages and disadvantages and what can be done if we want to use this RAD as our methodology in system development. Okay, and next, let me share my window. One moment. Okay, so we have seen this video, and finally, this is how our last topic for chapter 13. We now look at some of the common software development problems. I changed the bullets into a numbering, okay, so that we can see how many problems are there. The first one is the high maintenance costs. Maintenance costs, we look at in overall total software budget. And then the second problem is the software credibility, because some people, they do perceive that we cannot trust this system because they are error prone. Okay, so they are very skeptical about that. So we need to convince them. Not only software vendor will get the testimonial from the other companies using their software product. So to like increase the credibility of their software. Number three, the problem is about the software reliability, especially when we use it for safety critical processes, okay, like those in plants, factories, military, hospital intensive care units. So there's this issue, common problem when we're developing this type of software, where we want to really make sure that our software is reliable. Reliable means it will not crash or resulting in failure during that particular critical moment. And another problem is number 4. This is why we need you all. Okay, I hope 3 of you will be in the industry soon. Okay, there's an increase in demand in this system, information system. But then nowadays there's a slow in supply, means we have like we do have graduates, but not all of them they are really into software development. Therefore, we have backlogs. Okay. Number 5, the problem is on the software development. There's poor quality in the methods itself. That's why this chapter is dedicated to software development methodology. We have the intention of providing a high quality software for our client, but the one thing that we need to work on firstly would be the methodology that we use, because the methodology, if we use certain methodology, it will let me see, it will support us, or it will help us in achieving a high quality software product. I think I need to go back to the previous slide. I remember something here. The reason why we need the methodology. Yes, this one. The first reason, we want to have a quality software product, because having methodology can improve the quality of the end product. Okay, if we have a very good development process. Let me go to my slide just now. Okay, and then there's another 5 problems. Poor delivery of system. Poor delivery means most of the time not delivered as scheduled. Okay, if it's not delivered as scheduled, we cannot say that the system development project is a success. The 3 criteria would be BQT, budget, quality, and time. Number 7, the software cost that is quite expensive. And then at the same time, we are lacking in the knowledge to create or produce the software. Number 8, not meeting the user's needs. This is referring to the quality. We want to produce this particular system product, but if in the end it does not do what they are required to do, that doesn't serve the purpose. Okay, number 9, the high cost of software development. It can be due to reworks. Okay, they need to do rework because of some mistakes or incomplete requirements, or perhaps are lacking in the development tools. And finally, software portability. It's difficult to make sure that our system can run on different platforms, especially when we want to move on to mobile system, right? For mobile devices, we have various platforms. We have platforms for Androids, and another one would be for the iOS, right? Portability. And to ensure portability, we need to rely on good design practice. So you have seen these 10 common software development problems, and we have seen several system development methodology videos that show us the advantages, the disadvantages. Now, another question before we end our lecture would be, which system development methodology should we use? Okay, so I think a proper way to end our chapter is to share you all with this short video, 2 minutes video, choosing the software model, the software development model. Okay, the time is already 1:30. No worry, this one is very quick. Let me share this tab for you. 2 minutes video, and let's watch this.
Software process models. And there are many, many more. And because these process models define the master plan for our project, the specific process model that we choose has as much influence over a project's success as any other major planning decision that we make. Therefore, it is very important that we pick the appropriate model for our development process. Picking an appropriate model can ensure the success of a project. On the contrary, if we choose the wrong model, that can be a constant source of problems, and ultimately, it can make the project fail. So how can we choose the right model for a project? To be able to do so, we have to take into consideration many factors. In particular, we need to be aware of what level of understanding we have of the requirements. Do we understand all the requirements? Are we going to be able to collect all the requirements in advance? Or collecting requirements is going to be hard, and therefore we might want to follow a process that is more flexible with that respect. Another important point is the expected lifetime of the project. Is this a quick project that we're putting together for a specific purpose, or something that is going to last for a number of years and that we're going to maintain over all those years? That's going to make a difference in the way we decide to develop that project. Also, what is the level of risk involved? Do we know the domain very well? Do we know exactly the technologies involved? Well, if so, we might go with a more traditional process. Otherwise, we might want to be more agile, more flexible. It is also very important to know the schedule constraints. How much time, how many resources do we have for this project? What is the expected interaction with the management and the customer? In particular for this latter, there are many processes that rely on the fact that there can be a continuous interaction with the customer. If that interaction is not there, there's no way we're going to be able to use these processes. Conversely, there are processes that don't require the presence of the customer at all, except for the initial phase and maybe some check-in points. And so if the customer is very inaccessible, we might want to follow one of those processes instead of one of the more demanding ones in terms of customer time. Finally, it is important to take into account the level of expertise of the people involved. Do we have people that know the technology that we're using? Do we know people that know a specific kind of process? Some processes require some specific expertise, and we're not going to be able to follow that process if we don't have the right expertise. So we need to take into account all of these aspects and sometimes more in order to be able to make the right decision and pick the right software process model for our project. We just saw several software process models, and there are.
Okay, so with that video, okay, I believe it is a good video to end our chapter. All right, we have looked at the various system development methodology, right? And then there's advantages and disadvantages for each of the methodology. We have learned what's the reason we need methodology in our system development project and so on. Okay, so with this, yeah, we are at the end of our syllabus. Yay, end of syllabus, 13 chapters. So good job, everyone. So for next week lecture, I believe we will do more recap, okay, quizzes, and also some questions for practice before your final online assessment, right? So I'll end my lecture session today. Okay, and I'll see you all this coming Thursday.
Okay, Miss.
Bye.
Okay, Miss. Thank you.
Welcome.